All right, so we've talked about how endurance exercise is being coded, the duration by CAM kinase, the intensity by AMP kinase. But we've also got other things that are happening. So AMP generation is one signal, calcium is another signal, but we also have this important molecule, NAD. And NAD is a super important molecule, and you know that because when we look at glycolytic rate, if we're trying to maximize glycolytic rate because we're going really hard, we need to regenerate NAD, and we produce this thing called lactate, which everybody's heard of, okay? And so one of the things that we can do is we can look at the ratio of lactate to pyruvate, and that's a good estimate as to what's the content of NAD plus in muscle. So as we exercise, whether we're doing long, slow endurance exercise or higher intensity endurance or higher intensity exercise, we're going to generate more NAD. And so that's one of the things that's happening. And so NAD plus could actually be a signal as well. And so what does it do? Well, NAD can activate these series of deacetylases, a family of deacetylases called the sirtuins. And really, these are NAD-dependent deacetylases. And they're really sirtuin 1, 2, 3, 5, and 6 are the key ones. Sirtuin 1 is in most of the cell. Sirtuin 3 is much more in the mitochondria. There's a number of other ones. There's sirtuin 7 and a number of other ones that are important as well. But really what we're focusing on for this discussion is going to be on sirtuin 1, the most well-known and well-characterized of the sirtuins. All right, so what happens during exercise to NAD levels? So this is in people. If you're looking at relative NAD plus levels, young controls, young exercise, you see it goes up with exercise. Old controls, look at that, you've already decreased NAD levels. And sirtuin is something that's supposed to be important in longevity, and sirtuin is activated by NAD, so in the control muscle, the old are already decreased. So that's something to keep in mind. When we do exercise though, even an old fart like me, what happens? NAD plus goes up. And so that increase in NAD is something that's a component of exercise. And it's really, even if it's long, slow endurance, but we're going to focus on the role in short, higher intensity exercise. All right, so what happens is we increase NAD activity or NAD content in a muscle or in a cell. What happens is this is the rate of acetyl group release from proteins. And as we increase NAD levels, we increase the release of acetyl groups facilitated or enzymatically completed by this protein sirtuin 1. So sirtuin 1 activity goes up as NAD activity goes up. So then by definition, if exercise increases NAD plus and NAD plus increases sirtuin 1 activity, that should mean that exercise increases sirtuin 1 activity, and that's in fact what we see happening during exercise. So if we take, and this is a complicated slide, I want you to first look at the wild type sedentary and the exercise sedentary, so 0 hours post-exercise. And what you can see is if you measure acetylated P53, that's a target of sirtuin 1. What you can see is that the acetylation of P53 after exercise goes down. So the amount of the P53 is going up, but the acetylation of P53 is actually going down. And it's the relative acetylation that goes down significantly. Are we sure that this is a result of sirtuin 1? Absolutely. Because if you knock out sirtuin 1, this is a muscle-specific knockout of sirtuin 1, you eliminate the ability to cause the deacetylation of P53 as a result of exercise. And P53 is one of the most important tumor suppressor proteins in the body. And so what that means is that exercise is regulating this tumor suppressor protein. And it's really regulating the acetylation of this protein and the accumulation, because you can see that as it's becoming deacetylated, P53 is beginning to accumulate more. So you've got more of the protein, and it can do more of its activity, which is to suppress tumors. So what happens if we, because I didn't show to you with AMP kinase, but when you overexpress AMP kinase, you get an active form of AMP kinase, you get mitochondrial biogenesis. When you overexpress CAM kinase, you get mitochondrial biogenesis. And when you overexpress sirtuin 1, you get a partial mitochondrial biogenesis. You get complex 2, you get complex 4 going up, you get cytochrome C going up. You get an increase, but it's not everything. So it's important, and it can drive some mitochondrial biogenesis, but it's not a complete mitochondrial biogenesis. So you still need some other signals in order to get a complete mitochondrial biogenesis. So just like AMP kinase, which is coding for the intensity, CAM kinase, which is coding for the duration, sirtuin-1 seems to be coding for a little bit of the intensity and a little bit of the duration. So maybe it's more of a multiplier. So it seems to be getting both the intensity and duration. So it's an NAD-dependent deacetylase. NAD increases during exercise, and the higher the intensity exercise, the greater the increase in NAD. The rise in NAD activates sirtuin-1, and sirtuin-1 can increase many but not all mitochondrial proteins. So it's going to be important, but it's not everything associated with this. All right, so then how do we then look at this and say, okay, we're talking about coding for intensity, we're talking about coding for duration. So what can that tell us about when we should be exercising? Let's go back to this energetics graph that I gave you before. We can create energy really quickly from stored energy sources, ATP and phosphocreatine, and from the ADP coming together through the myokinase reaction. So we can create energy really quickly, but that only lasts for about 30 seconds. And at 30 seconds, we're transitioning from this ATP stored form to the glycolytic form. We're at that transition point. It's almost like you're driving a manual transmission and you're stuck in the clutch. You're trying to go super, super fast, but the clutch is in. And that's maybe something that's important, because at that transition point, we're using energy faster than we can produce it, because we're transitioning between one production form and another production form. And at that transition point, we're not as efficient. We can't produce energy as well. So when we're running for that period of time, when we're transitioning between 20 and 30 seconds, that's a time where we're using ATP faster than we can generate it. We're going to get lots of AMP kinase activity. The same thing happens at that other transition point from glycolytic to oxidative. That happens between 2 and 4 minutes. So if we're exercising at a high intensity that we can only hold for 2 to 4 minutes, that's going to again activate AMP kinase, because we're going to be using energy faster than we can produce it, because we're transitioning between the glycolytic and the oxidative energy sources. And the third zone that we want to get out into is this long, slow distance. And for you guys, everybody's different in what they consider long, slow. The long component is something over 10 minutes, really over 30 minutes. And so we can either be doing sprint intervals, 20 to 30 seconds, high intensity intervals, 2 minutes to 4 minutes, or long, slow intervals at 30 minutes or greater. Those are the periods where CAM kinase is going to be active, AMP kinase is going to be active at these two, because those are the transition points. So now what we're doing is we're coding. All of these exercises are going to activate sirtuin-1, but the high intensity, or the sprint interval and the high intensity, are going to activate AMP kinase a ton. The long, slow endurance is going to be much more CAM kinase. So those are the things that we're trying to do. You're coding for duration with CAM kinase. You're coding for these two sprint intervals, sprinting and high intensity, with AMP kinase. And that's why we consider the 30-second sprint, the 2 minute to 4 minute high intensity interval, and the greater than 30-minute long, slow endurance. Those are the three zones that we want to be working in. Okay? If we're going to do polarized training, 80% of our training should be this long, slow endurance. 20% of our training should be one of these two, either the sprint interval or the high intensity interval.